Okay, this is chapter 6, lesson 2, graphs of functions. Your objective is to write a function rule, and this is an example of a function rule. To use a table to graph functions and to find solutions of a function using a graph. Basically, if you know how to substitute values in, you're going to be fine. And if you know how to comprehend word problems, you're going to be fine. So this might be a little challenging for some of you. So in one city, the cost of a taxi ride is $2. I know that it's written on here, but I like to write stuff out. So I have $2 I know I'm spending per taxi ride. Plus $2 per taxi ride, and I'm going to have per mile, $2 per mile. So this is going to, M is going to equal the number of miles. How can you show, and then plus a base charge of $175. So then I have plus a base charge of $175, meaning it's just by itself. You pay it automatically no matter how far you go. How can you show the fare charges? How can you show the fares charged for all possible distances? So the cost will equal 2M plus 175. That will equal my cost, and that's exactly what's written here. The way it's written is C of M. So C of M will equal, mine's going to be written backwards. But like I said on yesterday's lesson, when an M is a given value, you just plug in M where it is, and that will be C of M, just like F of X. And it's going to make sense to you in the next slide. So let's go on to the next slide. So to show solutions of the function C of M equals 2M plus 175, you can make a function table. Choose several values for input M and substitute each value into the equation to find the corresponding output C. So when M is 1, I plug it into my equation. So it looks like C of 1 equals 2 times 1, because that's where M is, plus 175 equals 375. And the relation is miles traveled. So I traveled 1 mile, I paid $3.75. When I traveled 2 miles, I plug 2 where my M is. So I have 2 times 2 plus 175 equals 575. So I have, when I traveled 2 miles, the cost was $5.75. When I traveled 3 miles, the same thing, I plugged it in. 2 times 3 plus 175 equals 775. When I traveled 3 miles, it was $7.75. So if you're watching this video and you're actually listening and paying attention, that should make sense to you. If you have a certain question on how I got what numbers or what numbers I chose, or the book chose, therefore. The book just chose 1, 2, 3, because those are easy numbers. You can't go a negative number, like a negative mile, so that's why they're all positive. You could choose numbers like 5, 7, 9, but in terms of graphing, you want to choose the smaller numbers. It will be easier for you. So you can graph the above function on a coordinate plane, graph each ordered pair of the function, then draw a line to connect the points. A function whose graph, this is really important, a function whose graph is a non-vertical line is a linear function. So a non-vertical line means this is vertical, straight up and down. So non-vertical means any diagonal or anything that's not vertical is non-vertical line. So this is the example of a function graph. If you notice, there are no solutions in quadrants 2, 3, and 4 because it is not meaningful for a taxi ride to have a negative cost or negative distance. And that makes sense. So all solutions are the equation line on the line. Therefore, other solutions can be found by identifying the coordinates of any other point on the line. So the ordered pair 4 and 975 appears to be a solution to the equation. Check by substituting the coordinates in the function rule. So if I wanted to make sure that it worked, I'd plug in 4 to my value, and I'd get 2 times 4 plus 175 is 8 plus 175, and 975 equals 975, so it's true. So the point 4,975 stands for 4 mile ride cost $9.75. Some of you are probably wondering, do I have to write all of this inside my notebook? No, I want you to have all of your vocabulary. I need your vocabulary written in there. If you want a picture of a function table, then yes, you draw the picture. If your vocabulary doesn't make sense to you, then you need to go look up your vocabulary words and make sure it does. Okay, given a function table, you can write a function rule. What equation or function rule can be written to represent the relationship between x and f of x? And let me remind you, f of x is just equal to y. So a coordinate would be x, f of x, or x, y. So let's go ahead and do an equation. So to write a function rule, you have to look for a pattern. How can the given input generate the given output? So I have -1. How can I get from -1 to 1.5? Well, I can multiply times -1 times -1.5, but then if I go to 0 and I multiply times -1.5, that doesn't work. So then how do I get from -1 to 1.5? I can add -1 plus 2.5 equals 1.5. Okay, so that works for the first one, so let's see if it works for the second one. That means I'll plug in 0, where this is 0 plus 2.5 equals 2.5. It works. So then I have 1 plus, you're just looking for a pattern, 2.5 equals 3.5. So that one works. 2 plus 2.5 equals 4.5. So it works. So my solution for what equation or function rule can be written to represent the relationship between x and f of x? I can write f of x will equal x plus 2.5. That would be my equation. I'm going to explain that to you right now. So the pattern is if I do my input, which is x, I add 2.5, that's how I have plus 2.5, 2 and 5/10, will equal f of x, and that's why I have f of x. And that is how you figure out, that's how you write a function rule. Okay, so I want you to try this one on your own, so I want you to pause the video and see if you can figure it out. Okay, so if you pause the video, you should have realized in order to get, this one's a little different, I'm multiplying how do I get from 0 to 5? Well, I can add plus 5. Well, how do I get from 1 to 10? I don't just add plus 5, so I'm just not multiplying. So I need to figure out, okay, 5 times 0 plus 5 gives me 5. And the 0 comes from right here. Okay, so the next one I would do 5 times 1 plus 5 gives me 10, so that one works. 5 times 2 plus 5 gives me 10 plus 5, which is 15, so that one works. 5 times 3 plus 5 gives me 15 plus 5, which is 20. So these all work, and it shows it right here. So to write my function rule, I would have f of x will equal 5 times x, because that's where these numbers are. I'm going to go ahead and, these numbers are your x values, 0, 1, 2, 3, and then I'm going to add 5, 5x plus 5. That would be my function rule. Okay, so to write a function rule, it's a little bit more trickier. So you have to look for a pattern. How can the given input generate the given output? Okay, So to determine if a graph of a line represents a given function rule, choose any 2 points from the graph and substitute the coordinates into the function rule. If true statements result, the graph represents the function. So which graph represents the function y equals 2x plus 1? So I'm going to do one by one. Y equals 2x plus 1. If this point is 0, 1, 0, 1, that's why you can try 0, 1 and 1, 2. You always want to try 2 points because it might work for one and not the other. So if this was my equation, y equals 2x plus 1, I substitute my values in. So that's where I have 0. If y equals 0, y equals 1 and x equals 0, I plug it in. 1 equals 2 times 0 plus 1, 1 equals 1 is true. I'm going to try one more because it might work for one and not the other. So if y equals 2 and x equals 1, I plug it in. 2 equals 2 times 1 plus 1. 2 times 1 is 2, plus 1 equals 3, and 2 does not equal 3. So this one is not that function. So then I'm going to try it again on this one. Try 0 and negative 1, and I got that from this function, 0, negative 1. So y, my negative 1, I plugged it in, equals 2 times 0 plus 1. Does negative 1 equal 1? Well, no, I didn't even have to try a second one because the first one I tried doesn't work. All right, so the last one, 0, 1, I have y equals 2x plus 1. I plugged in where my x is, I plugged in where my y is. 1 equals 2 times 0 plus 1. 1 equals 1 is true. Then I plugged it in for 1, 3, 1 over 1 up 3, your x values first. 2 times 1 plus 1 is 3. 3 equals 3, so it's true. So this graph represents the function y equals 2x plus 1. Okay. So write a function rule that represents the relationship between x and f of x and graph the function rule. So number 1, I'm looking at all my numbers. I go from 0 to 6, 3 to 9, and then 6 to 12. What do I notice about each of them? So what I noticed is from 0 to 6, I can add 6. Let's see if it works for the next one. 3 to 9, I add 6. That works. 6 plus 6 will equal 12. So my relationship is adding 6. So that means f of x, which is this section, right? F of x will equal my x value plus 6. I want you to try to write a function rule for number 2 and number 3. And tomorrow when you come to class, I'm going to check it. If you don't have a function rule, at least tried for number 2 and number 3, then I'll probably know you didn't watch the video. The point of these lessons are so you're able to go back and watch which portion confused you. And if there was a real portion that I completely lost you in, you should be able to ask a real question, not, I don't understand any of it. That's not sufficient enough. I need to know exactly where I confused you. I can't read your mind, unfortunately. So you have to do your part when it comes to these video lessons. Some of you are starting to slack, and it's not going to help you. You have one more month left of school.